All right. How's everybody today? No, man. Okay. That's all right. Okay, we're going to continue with our inverse trig lesson today. We should be able to wrap it up tomorrow. In fact, before you leave today, I'm going to go ahead and pass out the assignments, which is due on Thursday. If all goes well, we should be able to go ahead and wrap it up with enough time tomorrow to answer questions on the assignment, even work some of that together possibly. But it's due on Thursday, and then we'll go ahead and begin the next lesson over inverse secant, inverse cosecant, and inverse cotangent. Remember, we have a quiz on Monday, which covers this particular lesson. It's going to be open-ended, and I haven't written it up on the board yet. I was thinking this morning I still need another CFA quiz. There's always 2 per 6 weeks, and I did the first one prior to Thanksgiving, but we need another one, so I'm probably going to go ahead and schedule that Tuesday or Wednesday. I'm actually going to go ahead and start working on that, hopefully today, if not tomorrow morning, but I'll let you know exactly when that's going to happen. But the big item is coming up on Monday the 16th. Okay, so a week from this coming Monday, that's when you have your second exam. It's going to be all over the inverse trig functions, these 2 lessons that we'll have talked about. With any luck, we will have started trig identities before then, but I'm not going to put that on the test. That'll be something that will continue past the Christmas break. I did get a little more information on what's going to happen tomorrow because we do have a fire drill happening when? It's during B lunch. So at the end of B lunch, probably about 1:10 is when Mr. Anderson said he would go ahead and set off the alarm. If you're in B lunch at that time, you're going to go ahead in the dining hall. You're just going to walk out to the east parking lot where the band would normally practice. And from what I understand, every teacher who has B lunch, like for example myself, I'm going to walk out there as well. I'm going to open my app, Navigate Prepared, and there should be an incredibly long list of everybody who should be at lunch. So the idea is for you guys to find a teacher and make sure you're accounted for. Okay, so it's only about 900 students. We should be able to do that, right? Yeah. So when I talked to him yesterday, he did admit that that would probably take a very long time. He said he'll probably only have us go maybe 15, 20 minutes until he feels we get enough students or we're good enough that we can go ahead and call time. All right, so it looks like we definitely will be missing the first part of 6th period tomorrow. All right, so any questions about that? Okay. If you're not at lunch, if you don't have B lunch, if you have A lunch, then you should be at class at that time. So your teacher will hopefully have already told you where to exit the building and all that good stuff. He or she will go ahead and take roll for you. But any questions about what's happening this week, the upcoming weeks, anything we need to talk about? Okay, well, let's go ahead and continue with this. Now, I've mentioned these previously. We haven't looked at them very much, and even today when we start looking at compositions, I'm really not going to go ahead and focus on these rules a lot. I mean, these rules are great if you can recognize them, if you remember them. But the thing is, like on the quiz we have coming up, the test we have coming up, I'm not going to allow you a note card this time. So if you're wanting to use these rules, I mean, for no better way of saying it, you'll just have to go ahead and memorize those. But even I don't have them memorized because I really don't think they're that useful. I think the better way to approach a composition problem is to evaluate the inside function and then use that answer to evaluate the outside function. In fact, I think you get a better appreciation for the concept if you go ahead and do it that way. And it just takes some experience. The more of those you work, you're going to start to see these rules anyway. So really, it just comes down to what you prefer. But we have been talking about inverses. Let me see. Who can I start with today? Kate. Sine inverse is restricted to what 2 quadrants? It is 1 and 4, between negative pi over 2 and pi over 2. Okay, very good. Joshua, what about cosine inverse? Where is cosine inverse restricted? What 2 quadrants? Well, now 2 is correct, but not 3. 1, okay, between 1 and 2. Okay, so between 0 and pi radians. And tangent inverse, Eli, is restricted to what 2 quadrants? It is also 1 and 4, just like sine inverse. Now, it's also between negative pi over 2 and pi over 2, but what's the big difference between sine inverse and cosine inverse, or tangent inverse, excuse me, even though they're in the same quadrants? That's exactly right. Andrew says the asymptotes. Sine inverse can use the boundaries, negative pi over 2 and pi over 2. But tangent cannot. Tangent is undefined at those locations. So while those are the boundaries, we can't include them for tangent inverse. And what we did yesterday, we talked about cosine inverse, then we did some problems. We went through tangent inverse, and we began working some problems. How far did we get? So we got A and B done? Okay, and now we're ready for C. Okay, so let's go ahead and take a look at C. We'll just get right into it. So I want tangent inverse of 0. Now, these problems all have, certain steps to them. The first step is we want to go ahead and figure out what quadrant I'm going to draw my triangle in. But does anybody notice anything about this particular problem? It is 0. Okay, so 0 is neither positive nor negative. We always decide what quadrant based on the sign of my ratio. So here, we really can't say one or the other, but can anybody know what the big picture, what's going to happen here? Okay, say that again, sir. It's going to be on one of the axes. What do we call that? Here, it's a quadrantal. Now, let me just kind of revisit this very quickly. Let's say we don't realize it's going to be a quadrantal. Okay, so we just choose a quadrant. Let me go ahead and say quadrant 1. And it really doesn't matter what quadrant we choose. Okay, so tangent always has a ratio of y over x. So if you're given, a value that's not a fraction, you can easily go ahead and make it a fraction. Just put it over 1. So I've given a definite y and a definite x. So I know this is 1 and this is 0. But can anybody see why the problem exists? You can't have a figure where one side length is 0 units long. So I'm not able to draw a triangle. It has to be a quadrantal. It has to be on one of the axes. But here's the thing. Think about what we just said when it comes to tangent inverse. Now, tangent inverse is restricted to quadrants 1 and 4. That's true. But those boundaries, negative pi over 2 and pi over 2, tangent inverse can't include them. So what is the only remaining axis I could use? It has to be the positive x-axis. Okay, so it has to be this one right here. In fact, what's the ordered pair at that location? It's 1, 0. There we go. And remember, tangent always wants the y value divided by the x value, so tangent inverse of 0 should be 0. Okay. All right. Okay. Questions on that? All right. Well, let's move on with D. And again, I'll go ahead and connect it to what we've been doing since yesterday, even before the break. I want tangent inverse of 5. So let me write this out again. So tangent inverse of 5. If I evaluate an inverse trig function, what's my answer going to be? Is it a ratio or an angle? It's always an angle measure. You can only plug ratios into an inverse trig function, and you're going to get yourself an angle measure. So if I were to take that angle measure, if I evaluated tangent with that, well, it should give me the original ratio that I was dealing with. Remember, there is a relationship here. When we're taking the inverse, we're just switching those two quantities. Normally, we say we switch the x and the y, but here we actually have ratios and angle measures. Is everybody okay with that? Okay. Well, tangent inverse of 5. It's got to be quadrant 1 or quadrant 4. Which one would it be? By 1. It's positive. You always use the sign to determine the quadrant. So I'm going to go ahead and draw a terminal side here. Okay. There we go. So 5, just like the previous problem, is not a fraction. So I'm going to go ahead and make it a fraction. So now I have a y value and an x value. So I know this has got to be 1, this has got to be 5. Now, it's not necessary to solve the problem, but we'll go ahead and find it anyway. What's the hypotenuse? It is square root of 26. Okay, would anybody like me to go ahead and run through the Pythagorean theorem? Okay, so let's say we don't know the radius. So right now, let's just go ahead and say it's r. Okay, so I'm going to go ahead and say that r squared is equal to 5 squared plus 1 squared. So r squared is equal to 5 squared, 25, plus 1 squared, 1. So r squared would equal 26. And how do I get r from r squared? Take the square root. There we go. So that's where we got the square root of 26. Okay. Now, what I'm looking for is this reference angle that's created. Remember, when you evaluate a trig function inverse at a ratio, your answer is an angle. So I want this angle measured right here. Well, is this a special right triangle? Unfortunately not. Now, I do want to know what that angle is. So what does this mean? We have to go ahead and use our rulers and or our protractors to measure it out. So the good news here is if you want to go ahead and use millimeters, centimeters, inches, it's completely up to you. The two values we have are whole numbers. Okay, so we can just easily do that. Let me come on over here. So in quadrant 1, I want to recreate this triangle. Okay, I want 1, 5, and again, we don't have to really worry about the square root of 26, but I'm going to go ahead and put it there. Now, typically, I like to go ahead and measure in centimeters, unless, of course, there's a radical expression. That's the only time I usually convert it to millimeters. Excuse me. So what I'd like for somebody to do is come on up here, because I've done several of these myself. I'd like somebody to come on up here and practice with the rulers and the protractor. Who would like to go ahead and measure out this triangle and then figure out how far I rotated from standard position? So many hands. Okay, I do have a random number generator already up, so I'm going to click generate. 23. Okay, so would that be Clarissa? And she is not here today. Oh, darn. 19. I believe that is Philip. All right. Where is it? 19 minutes ago. Okay. So I want to recreate that triangle that we were looking at right here with the exact side lengths. Bless you. Okay, now, careful. Do we want to go ahead and start it at the edge of the ruler? Because that's not where the measurement begins. Oh. Hello. Oh, thank you very much. Do you have a calculator, ma'am, or do you have your? I have my calculator. Okay. Okay. So you can see what we're referring to? Okay, so let's go ahead, pull this guy back here like this. So you see, the measuring doesn't begin at the edge of the ruler, it begins right here. So we want to go ahead and make sure to put that on my axis. There we go. Okay, so there's 1 centimeter. Okay. There we go. And then from there, we want to go ahead and go up 5 centimeters. Okay, perfect. Yeah, and I'll go ahead and draw this last one for you because we want it as straight as possible. When you're drawing the hypotenuse, that's what you're going to be measuring on your protractor. So you'll definitely want to use a straight edge for that one. So I'm going to help him out here. I'm going to start at the origin, and I'm going to go ahead and put it right through where he ends that vertical segment right there. Okay, so from here to here, that's what I'm trying to measure. So let me get rid of this ruler for you. Okay, and I'll let you go ahead and take over with the protractor.
So I place it at the origin, right?
Yes, you want to place the crosshairs right at the origin. So go up just a little bit. There you go. Okay, and then you just want to go ahead and now look. So it looks like it's right about here. So how far did we rotate? 79? Okay. What do you guys think? 78? All right, you got 79. Okay, so Jordan is saying 78.5. Okay, so we all agree we're getting right about the same value though, right? So what would you like to put as an answer? Nelly, what do you think? Okay, he wants to say 78. Okay, Philip would say 79. But now let's go ahead and try that. All right, now my calculator is in radians, so I'm going to have to go back very quickly. I'm going to go into settings, document settings, change this to degrees. Okay. So now let's see, this was tangent inverse of 5, 78.7. All right. So let's say, had this been a problem on a quiz or a test, would they be getting credit for this? Absolutely, absolutely. Remember, because we're measuring these particular problems by hand, there's going to be a little wiggle room. I'm going to allow you some values above and below. There's going to be an interval that I'll allow that answer to fall into. You know, at some point it has to be too far off. I'll have to take off credit. Yes, ma'am. I'd be okay with 80. Yes. Okay, because this right here is right really close to 79, so I'd be okay with that. I'd probably go like 2 or 3 above and below. Okay, depends on the values that we have. All right. Yes, Will.
Is grid paper reliable for like using instead of a ruler? So like.
You know, grid paper should work because each of those are the same increment.
Yeah.
So like 1 and 5, it should create the same triangle. It should be similar.
Yeah.
So I would imagine if you want to use that, yeah. Okay. All right. Any questions on this particular problem or tangent inverse in general? Okay. Well, let me go ahead and document B out of here. Let me go ahead and erase this so I'm ready for the next class. Okay. So good job. Good job. Good job. Okay. All right. Moving on. Let's see here. Okay. Now the next section here, use a calculator in radian mode to approximate the expression. Round your answer to 2 decimal places. Okay. So we're also going to be able to use this as kind of a refresher on those intervals, what we're allowed to input into a trig inverse function, and the answers that we're going to get out, why we're restricted to certain quadrants. But first, you'll notice I got to put my calculator back in radian mode. So just in case your calculator is not, this is what you're going to do. Go to your home screen. You're going to go to settings. Okay. Now, my calculator has several more options that's going to pick up for you, but what you need is document settings. Okay, right here. And then the second one down where it says degree, click on that drop-down menu. You'll want radians, but make sure to click make default. If you just click OK, it'll go ahead and keep it in radians for one operation, and then it'll go ahead and revert back to degrees. So if we want to make sure it stays in radians, we're going to click make default. Yes, that's what I want. Okay. Now, before we go ahead and go to the calculator on this problem here, let's go ahead and talk about this. What does negative 0.74 represent? Is that a ratio or an angle? It's a ratio. You can only plug a ratio into an inverse trig function. So this is a ratio. So the answer that I'm trying to find, that's an angle measure. Okay. An inverse trig function will only provide you an angle measure. Now, whether degrees or radians depends on what you're working with or what you were asked to provide. Now let's talk about the intervals. Does anybody remember what's the interval that a ratio has to fall between for sine inverse? Has to be between what 2 numbers? Oh, -1 and what? I heard -1, but what's the other one? 1. There we go. The ratio has to fall between -1 and 1. Now, what about your output, your angle measure? It has to be what? Now, remember, we're restricted to quadrants 1 and 4. Oh, not 0 and pi. Negative pi over 2 and pi over 2. Remember, because those would be considered the boundaries for quadrants 1 and 4. Okay. So is this one okay? Is a negative 0.74 in the interval from -1 to 1? Yeah, so I should be getting an answer. Okay. So I'm going to go ahead and say sine inverse of, what is it, negative 0.74? Okay. So I'm getting negative 0.83. Okay. Do you guys agree? So this is negative 0.83 radians. Now, maybe it wasn't really necessary to go ahead and switch my mode to radians. Let's say I'd left it in degrees. What could I have easily done to go ahead and get the negative 0.83? Or not move the decimal. There you go. How do I convert degrees to radians? You multiply by pi over 180. I could just have done that without having the mode in radians. So it's really up to you. Now, cosine inverse follows a lot of these same ideas. I'm only allowed to plug a ratio in. Okay. What I'm going to get out of it is an angle measure. Okay. Now, cosine inverse has the same restriction on the ratio that sine inverse does. It has to be between -1 and 1. But Connor actually said this a moment ago. What's the output boundary interval? Now it has to be between what? 0 and pi. So cosine inverse is in quadrants 1 and 2 between 0 and pi. But does anybody notice anything before I even go to the calculator? Does 1.5 belong to this interval? It does not. So this is already telling me I shouldn't be able to get an answer out of this. So let's say you don't know or remember that restriction. If I come over here to the calculator and I say, okay, I'm looking for cosine inverse of 1.5, see, it's going to tell you there's an error. You're not going to be able to get an answer anyway. Okay. So I'm going to come back over here. So that will not work. Okay. All right, how we doing? All right, moving on to C. Sine inverse of sine of 2.36 pi. So for these C and D, I am going to go ahead and again kind of bring up those composition rules. But again, I just want to really show you more that they're there if you want to work with them. Sine inverse of sine of 2.36 pi. So let me go ahead and type this in. So sine inverse, okay, of sine of 2.36 pi. Okay, so anybody help me out? What would I get if I were to go ahead and push enter? Okay, so I'm going to get like 1.13. It wanted me to round to 2 decimal places, right? So this is 1.13 what? Okay, is this radians or is this a ratio? And this is something that we'll be talking about with the composition in just a minute. What would my final answer be? An angle measure or a ratio? Remember, an inverse trig function is only able to provide an angle. Because sine inverse is the outside function, the answer I get is an angle measure. So in this case, what was it, 1.13? 1.13 radians. Now, this is something that's going to come with just practice, working with these. You'll start to notice it. If I were given this particular problem, I've been doing these long enough, I would go ahead and say that my answer is 0.36 pi. Okay. Now let's take a look at this. If I were to go ahead and plug in 0.36 pi, it gives me the exact same decimal that the composition did. Why is this? Why does that work? Multiplying by pi? Okay, well, let's go ahead and compare it to that particular rule. See, we have sine inverse of sine, right? So let me go right next to this. So sine inverse of sine of x equals x, but only if x falls within this interval, right? So what that's telling me is that 2.36 pi, whatever its decimal value is, doesn't belong to this interval. But why does 0.36 pi work? I'm fishing for one particular word. Can anybody tell me? It starts with a C. A vocabulary word that we used way at the very beginning when we started looking at trig. Coterminal. That's exactly right. So let me come back and kind of explain this. 2.36 pi, could this be 2 pi plus 0.36 pi? Would that give me 2.36 pi? So just think about the unit circle as you rotate around. One full revolution, that's what? That's 2 pi. So I've already taken care of that. So I would only have to rotate an additional 0.36 pi. And would 0.36 pi fall in that interval that the composition was talking about? Yes, 2.36 pi and 0.36 pi are coterminal. That's why you get the answer that you do. Okay. Now for D, I'm going to go ahead and solve it using the composition rules, but then I definitely want to come back and revisit this one because it's very unique. Okay. So let me go ahead and erase this here. I want tangent of tangent inverse of -4. So I'm going to come on over here. So here's the rule I'm looking at. Tangent of tangent inverse. Now, the answer is the input as long as it's what? It's all reals. Well, is -4 a real number? Yeah. So this one here should be -4. So see, those rules do make things a lot easier. We don't have to do any work to go ahead and show that. But it's really only useful if you know that rule. If you don't know that rule, then you're going to have to evaluate the composition. Now I'm going to come back in just a second, and I'm going to go ahead and show you this one right here. Okay? But in order to help you with D, let's come on down here to this next set. Now, I'm going to go ahead and skip A and B. If you take a look earlier in your notes, you're going to notice we actually already solved those specific problems. So I must have been a mistake why that was put on there, unless anybody wants to revisit one of those problems for any reason. Okay, then we're just going to go ahead and move on to C. Now, C is kind of an unusual problem, but to help you with it, I'm going to give you an easier one. Cosine inverse of cosine of -pi/4. This is an extra problem I'm going to go ahead and give you. Now, I strongly recommend that without knowing those rules, go ahead and use the composition. Actually evaluate the inside function and then plug that answer into the outside function. Okay. In fact, for these two compositions right here, what would my final answer be? Is it going to be a ratio or an angle measure? How do we know it's an angle measure? What's the outside function? In both cases, it's an inverse, and an inverse is only able to give you an angle. Okay, so I think part of working these compositions is knowing what type of answer you should be getting. So I'm looking for an angle measure. Okay, now the first thing I want is cosine of -pi/4. Right? So cosine of -pi/4. So this is just a happy minutes problem. I'm evaluating a trig function at an angle measure. What quadrant would -pi/4 put me in? It put me in 4, so I'd have to rotate clockwise. Okay, so it'd be something like this. Okay, but -pi/4, isn't that just -45 degrees? Okay, so this is a 45, 45, 90. Now remember the unit circle. This is where that concept is coming back. If the radius is 1, what are the identical side lengths? Ooh, now pi/2, that's an angle measure. I need a ratio. Square root of 2 over 2. Am I missing anything? Remember, we're in quadrant 4, so the y value would have to be negative, right? Okay. But what does cosine want? Cosine wants the x value. Now, by definition, it's always x divided by r, but here the radius is 1, so that really doesn't play into it. So what is the x value? It's the square root of 2 over 2. That's the answer for this inside function. Well, now I'm going to take that output, the answer, and I'm going to plug it into the outside function, and I'm going to evaluate one more time. So now I have cosine inverse of the square root of 2 over 2. See, I took the answer that I got from the first one, and I'm plugging it directly into the next one, just like we worked with compositions before. And this is the exact same type of problem we saw yesterday. Cosine inverse is restricted to 1 and 2. Jake, what quadrant would square root of 2 over 2 place it? Why 1? Because it's positive. So I'm going to go ahead and draw this right here. Okay. So remember, cosine is always x over r. So the x square root of 2, the r 2. Can anybody tell me what that missing side is? It is square root of 2. Would anybody like me to run through Pythagorean theorem? Okay. Well, do you notice anything about this triangle? It is a 45, 45, 90. So what is cosine inverse of the square root of 2 over 2? it's 45 degrees. Or pi over 4. Okay. All right, so knowing this, we've already seen a problem where it worked out very nicely for us. Let's go back to C. Okay. Does anybody want to go ahead and predict what cosine inverse of cosine of negative 1.1 will give me? Okay, Philip? Okay. Negative 18 degrees. I actually don't know what the equivalent is. So I don't know off the top of my head if that's right or not. But just take a look at what we did on the previous one. Cosine inverse of cosine of negative 1.1. What would the answer be? What was cosine inverse of cosine of negative pi over 4? It was just pi over 4, right? This one would just be 1.1. Now this one becomes a little more abstract. You really have to know the definitions in order to work through this. So let's do the same thing for C that I just did for this problem. Okay, so I'm going to go ahead and erase all this. So we know the answer should be 1.1. Okay. So the first thing I want to do is evaluate the inside trig function. I want cosine of negative 1.1. Now that negative 1.1, is that a ratio or is that an angle measure? It's not a ratio. How do we know it's an angle measure? Because it's just cosine. The only thing I'm allowed to plug into a trig function is an angle measure. Okay, so where would negative 1.1 radians put me? What quadrant? Okay, not third. It'd be, what's that, central? Not second. It'd be in the fourth quadrant. Okay. Now, we know it's negative, so I have to go ahead and rotate clockwise, right? So if I'm in radians and I'm rotating clockwise, well, the first one I'm going to come across is negative pi over 2. Whoops. Just dropped my marker. So to show you that it would be in quadrant 4, let me go ahead and document B out of here. Control divide negative pi over 2 has a decimal value of negative 1.57. So negative 1.1 would be in quadrant 4. Is everybody okay with that? Okay. So here's the thing. I'm going to go ahead and rotate into this quadrant. This is the negative 1.1 radians that I rotated into. Now, if I evaluate a trig function at an angle, what answer am I going to get out of this? Would it be an angle or a ratio? It's a ratio, right? So see, here's the thing. We don't know what these three side lengths are going to be. I know that this is x, I know that this is y, and I know that this is the radius. But cosine always wants x over r. Now, we may not know what that ratio is, and it come to find out we don't need to know what that ratio is. The only thing I need to know about this is it positive or negative? So look at the quadrant we're in. Would x divided by r be positive or negative? It'd be positive. Now, first, the radius is always positive, right? But in the fourth quadrant, x is also positive. Okay. Now, we're going to do what we did before. This answer that I got from the inside function, I'm going to plug it into the outside function. So I want to go ahead and find cosine inverse of x over r. But there's probably some folks out there thinking, what are you doing? How can we do this? We have no idea what x and r represent. That's okay. Think about cosine inverse. What two quadrants is he restricted to? 1 and 2. How do I decide which quadrant? The sign. What did we say about x over r? It's positive, so it would be in quadrant 1, right? So I know that this would be x, this would be r, and I would go ahead and use those two values to find the third missing one. Do you notice what I just did? What just happened? What do I know about these two triangles? Those two triangles are what? They're the same. They are exactly the same. So if they are congruent, what do I know about this angle right here? Wouldn't it have to be 1.1? But we're in the first quadrant where it would be positive. This is what I want to spend some time practicing, making sure we feel confident with these. Now, with this in mind, let's now go back and revisit D. We use the rule to go ahead and say that tangent of tangent inverse of -4 is -4. But now let's work through the composition. Okay. Let's start with tangent inverse of -4. Okay. Now, tangent inverse is restricted to 1 and 4, right? Which one? Why 4? Because it's negative. Okay. So we're going to start there. Now, -4 isn't a fraction, so I'm going to make it a fraction. And remember, tangent always has y over x. So I know that this right here is -4. I know that this would be 1. What would the hypotenuse be? Square root of 17. Is everybody okay with how we got that? Or again, would anybody like me to run through the idea? Okay. All right. Now, what is tangent inverse of -4 ultimately going to give me? Is this a ratio or an angle measure? It's got to give me an angle measure. Specifically, it has to give me this angle measure right here. Okay. Well, unfortunately, in order to find it, we would have to go ahead and measure it out, right? Why is that not necessary here? Whether I know that angle or not, what would I do with it? Wouldn't I just go ahead and plug it into tangent? But now, what's tangent of theta? Opposite over adjacent, or -4. So there are certain composition problems where you may not know the ratio and you may not know the angle measure in order to get the final answer. And you don't need to. Could we go ahead and find theta? We could, but I don't think it's necessary. If you just go through with the definitions, if you know what you should be getting, it's going to make it a lot easier. Okay. That's really what I want to go ahead and practice tomorrow. Now, there are a few extra ones down here. Okay. These are actually, a lot more straightforward. So hopefully it makes some people feel better before we leave. Okay. Now, take a look at these. These are different compositions. You'll notice that the outside is just a normal trig function now, right? What should my final answer be? My final answer should be a ratio for these. Okay. So for compositions of this type, my final answer should be a ratio. All right. Well, let's just run through it. Cosine of sine inverse of a -1/2. Okay. Where do I start? Do I start with the inside or the outside function? Inside function. Okay, so I want to evaluate sine inverse of -1/2. Okay. Sine inverse is restricted to 1 and 4. What quadrant would I go into? Why 4? Because it's negative. Okay. So I'm going to go ahead and draw a triangle here. So is everybody okay? 1, how I chose the quadrant. Okay. Now I'm going to go ahead and create the side lengths based on my ratio. Remember, sine is always y over r, right? So I know that the radius would be 2. I know the y value is the -1. What's my missing side? It is square root of 3. Again, any takers on Pythagorean theorem? Okay, next question. Is this a special right triangle? Yes. Okay, so what would be across from this -1 right here? That's 30. This one would be the 60. So what is sine inverse of -1/2? Oh, it's not 30. -30. Remember, in the fourth quadrant, you have to rotate clockwise to get in there. So this is -30. What am I going to do with this -30? I'm now going to take that and plug it into the outside function. Sine inverse of -1/2 was -30. See, now this is just a good old-fashioned happy minutes problem. Is everybody okay? And we just evaluate one more problem. Where would -30 place me? Quadrant 4. Okay. Here we go. So here's -30 degrees. I remember the negative just tells me direction. Okay. So being on the unit circle, I know the radius is 1. Does anybody remember what's across from 30? Okay, 1/2. What's across from 60? Square root of 3 over 2. Am I missing anything from my diagram? It's not going to affect my answer. The 1/2 would be negative because of the quadrant we're in. Now remember, what does cosine want? Cosine wants the x. Now, by definition, x over r, but here the radius is 1. So what's the x value? Square root of 3 over 2. So I did get a ratio as my final answer. Okay. See, all I did was work the inside problem and then the outside problem. I just worked through the composition. Okay, let's try the next one. Sine of cosine inverse of 5/13. Okay, so the first thing I want is cosine inverse of 5/13. Okay, so let's see here. How about Emma? What quadrant would I start with? Now remember, where is cosine inverse restricted to? I keep forgetting. What 2 quadrants? 1 and 2. So Emma, would I start with 1 or 2? Okay, why 1? Well, she's right, but can anybody tell me why it's 1 and not 2? Use the sign to tell you the quadrant. That's a positive 5/13, so it's absolutely right. Okay, so I'm going to go ahead, set this up. Now remember, cosine is always x over r, right? Okay, so I know this is 5, this would be 13. What's the missing side? This is a triple. It is 12. It's a 5, 12, 13. But again, Pythagorean theorem would easily get you that remaining side. Now, cosine inverse, that answer is going to be an angle measure, specifically this angle measure. Okay, here's my question. Do I need to know what that angle is in this particular problem? I don't. Because whether I know that angle or not, what am I going to do with that angle now? I'm just going to plug it into sine. So using this same triangle, what's sine of theta? Remember, what does sine want? Sine wants y over r, so 12/13. So could we have gone to the trouble of finding theta and then plugging that into sine? Yeah, but there are times when that's not necessary. Okay, just think about what your final answer needs to be. Okay, are we ready for one on our own? Yes, all right. Okay. All right, so let me go ahead. We have only one problem left on the notes, and it's an application problem, but I have several example of compositions here. We're going to go ahead and continue this tomorrow, and then I'll finish with the application. So let's try this one. Cosine inverse of sine of pi over 3. Okay, cosine inverse of sine of pi over 3. What is my final answer going to be? A ratio or an angle? It has to be an angle measure. How do I know that? There you go, because the outside function is an inverse. Okay, an inverse trig function is only capable of giving an angle measure. All right. Now make sure that your final answer is in radians as well. Okay. And while you guys are working on that, let me go ahead and pass out your assignment. Remember, when's the assignment due? This is due Thursday. Here we go. So if you've got the answer and you want me to go ahead and check it, you can go ahead and raise your hand, and I'll walk around and do so. Okay. Philip believes he has the answer. Where is it? There? No, sir. I'm sorry. Remember, we know that because the outside function is an inverse, we should be getting an angle measure. An angle measure, not a ratio. Kaushal, you think you have it? Okay. Oh, Will. Where is it? That is correct. First one right. Okay, so Kaushal, you don't have it? Okay. Anybody else raising their hand? Sandra? Perfect. That's 2. Okay. Philip wants me to check him again. That right there?
Yeah.
No, sir. Remember, it's an angle measure, not a ratio. Anybody else? Eli? I don't know what the decimal equivalent would be. Let me go ahead and take. That is correct. That's correct. Okay, now remember, though, we won't be going decimal answers on the quizzes and the test. We'll be going with the approximated values. Where is it? No, sir. Correct. Did you get the same thing? Got something different? Okay. No, sir. Sorry. What, right here? No, sir. I'm sorry. There you go. Perfect. Okay. Galen? Okay, it's a decimal. That's correct. Okay. There we go. No, sir. All right, so remind me tomorrow, because that bell's about to ring. We'll go ahead and start with this one, but your answer should be 30 degrees or pi over 6 radians. Okay, preferably pi over 6. Okay, now before you leave, don't forget about my calculators, protractors, or rulers if you happen to grab one. Let me go ahead.